All right, so I don't think that we quite covered well enough the generating a truth table from a circuit. We did go over it a couple of times, but we just went only to the level of the table. We didn't put it back into a formula form, that is back into the sum of product form, and that's the way the answers are in the book. So I think that might be a bit confusing. And the fact that we only went over it a couple of times, I think it just deserves a bit more observation. So hopefully, if you're stuck on this will help a little bit. Okay, so the first thing we want to do when developing a truth table from the form, and there's a couple of ways of doing this, and I'll show you the most common way. I don't think it's the most efficient, but it is the most common. It's what you see if you log on to YouTube or whatever. And that is wow, we don't want that. That is to label each output area with some letter. So I'm going to use E, F, and I'll use Y for the actual final output because that's what the book uses. Having done that, then I need to represent each of these outputs on this table down here. So I have E, F, and then my final output of Y. Okay. Now, so I've set up the guides. We, of course, have to set up our guides. We have 3 inputs, A, B, and C. Note that B is negated here, and that negation feeds into both E, or this top gate and this lower gate, which are both AND gates. So we develop our guides, and then we just simply calculate what E is. And remember that E is comprised of A and not B. So really this up here is A and not B. It's really kind of a crummy little not sign there. Let me see if I can get that to... There we go. Okay, A and not B. So for all of these, 0 and anything is 0. 0 and anything is 0, and that'll carry on. 0 and anything is 0. 0 and anything is 0. Here I have a 1. B is 0 negated into a 1, so that's true for this equation, or this expression. A again is a 1. B again is a 0 negated into a 1, so that's true for this expression. This line is true for this portion of the problem. A is 1, B is 1 negated for 0. Any 0 in an AND statement gives us 0. Same thing here. A is 1, B is 1 negated into a 0. That's enough to make the whole overall statement 0. So we have 2 1s here on this output for E. We then do the same thing for F, and it is, pretty much the same, except that C is going to hit its maxes, its highs at different areas. So, okay. B is 0. B negated is 1. C is 0. 1 and 0 is 0. B negated is 1. C is 1. 1 and 1 is 1. B here is 1. Negated is 0. 0 and anything is 0. B is 1 here. Negated becomes 0. 0 and anything is 0. B is 0 here, negated for a 1, but C is 0, so anything and 0 is 0. B is 0 negated to a 1. C is 1, so our output here, 1 and 1, is 1. B is 1 negated to a 0. 0 and 0, of course, is 0. And finally, B is 1 negated to a 0 is 0. Okay, so that takes care of our F gate there. You'll note that the Y gate is simply and I want to say that the F gate is, of course, negative B and C. That's what we did for the F gate. The Y gate, of course, is just a mix, is an OR combining a disjunct combination of E or F. So we're going to go ahead and just take each of these and combine them with an OR in order to get our output. 0 or 0, of course, is 0. 0 or 1 is 1. 0 or 0 is 0. 0 or 0 is 0. 1 or anything is 1. 1 or 1 is 1. And 0 or 0 is 0. 0 or 0 is 0. Okay, so this gives us our truth table. We are most of the way there at this point. The next thing we have to do is to create a sum of product expression from this truth table, and we do that exactly the same as we did it when we were going from just the output to creating this circuit. That is, I'm going to go look and see where my max terms are. So I have a max term here, I have a max term here, and I have a max term here. Everywhere I have a max term, that is this line. Let's see. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5, 5. This line, sorry about that, I'm losing my column or my rows here, and this line. So on these three lines, I have a max term. So I'm going to take whatever the value of our guides are for that line. So on our first one, we have A is low, B is low, C is high. So A is low, B is low, and C is high. So there's our first one. Next, here we have A is high, B is low, C is low. A is high, B is low, C is low. Note that I'm putting this in the form of a sum of product, so an S.O.P form, which is our max term form. Okay, and our final line, A is high, B is high, low, and C is high. So A is high, oops, that way. B is low, and C is high. Okay, and this should actually produce what's in the book in reverse, because he starts with ones. He starts with ones across the top here, and I start with zeros. He develops my top lines on the bottom of his, and my bottom lines on the top of his. So he basically, by starting with ones, he flips it the other way, and thus the terms come out the other direction. But that's okay, because commutation tells me I can put them however I want to, because they're all joined by an OR. So let's check our answer real quick. Hold on one second. And this is problem 7.25, I believe we're doing. 727. So this is problem 7.27B is the problem we're doing here, okay? And the answer to that is A, low B, C, so there's that. A, low B, low C, so there's that. And low A, low B, and C, so there's that. So we developed the proper equation, albeit in the reverse from what he has, which is no big deal. Okay, so that is basically how you do that. There is, you don't have to actually utilize the EY, this EYF moment. You can actually simply utilize the final formula for the output. So I can, let me get, I'll put this. So rather than doing this, I can do, and I'm going to get rid of that, get rid of, sneak in there, sneak in here, and sneak in right there. Okay, good. So let's see, you go back down, 4, 5, 6. Oops. Okay. So here's my output for this is A and not B. My output for this gate is not B and C. My final output then are these two joined by an OR. So it is A and not B, or not B and C. So rather than doing E and F joined by an OR, I'm just going to do the whole equation, right? Just going to calculate that equation. Going to go ahead and make one singular line here across this. And I'm just going to write this equation here. A and not B, or not B, oops, not B and C. And I'm going to keep our other answer there just for giggles and get rid of some of this slop that I have up here. So get rid of this, make some room for what we're about to do. All right. Bump. So we can then just monitor. We are concerned about our final output, so we're really concerned about that one. So, we can just watch that one and see where it goes. And let's go ahead and do this. 0 and 0 is, of course, 0. And not B, 0, B negated. So not B is 1. So 1 and 0 is 0. 0 or 0 is 0. 0 and 1, so 0 negated. 0 and 1 is still 0. 1 and 1 is 1. 1 or anything or 1 is going to be 1. 0 and anything is 0. So we're on line 3 here. So that's this line, this line, this line. B is 1 negated to 0, 0, and anything is 0. 0 or 0 is 0. Here we have 0 and anything for the A is 0. And then B is 1 negated to a 0, so 0 and anything here is 0. 0 or 0 is, of course, 0. Then we get A is 1. B is 0 negated to a 1, so 1 and 1 is going to be 1. 1 or anything is 1. Then A negated to a 0, or sorry, A is 1, B negated from 0 to 1, so 1 and 1 is going to be 1. 1 or anything is 1. Finally, A negated, or A is 1, B is 1 negated to a 0. Anything and 0 is 0. B negated to a 0 is 0 over here. 0 or 0 is 0. And we have the same situation here. We have B negated to a 0, which gives us a 0 here. B negated to a 0 over here, which gives us a 0 here, giving us an overall 0 or 0. Okay, so we developed exactly the same formula. We didn't do the E and F as E and F, but you see by just simply substituting back in the actual values for E and F, we get the same thing. You just have to make sure that we're monitoring the primary or the primary term, but the major term. So that's this right here. So we monitor the major term, and anywhere that we have a 1 here, we're going. That'll be our max term. That's our output. So anywhere that our output, this output here, this is what's being output. Anywhere that that's 1, we go ahead and list the line for that, and you see we're actually just listing exactly the same lines again. So I'm not going to go through that. You can see that this is going to develop exactly the same formula. So that's how you go about. I wonder if I should list that. No. You could let me walk through it really quickly. You can see here that A is low, B is low, C is high. A is low, B is low, C is high. A is low, B is low, C is high. A is high, B is low, C is low. A is high, B is low, C is low. Here, A is high, B is low, C is high. A is high, B is low, C is high. So we get the same thing. I just wanted to walk back through developing that in case you kind of didn't see it the first time very well. That is how you develop a truth table from a circuit, and then, which the book doesn't quite go into, put that truth table back into sum of product form, and that's the way the answers in the book are given. So, okay, great. I hope this helps.